Hi to everyone, welcome to NCC channel. My name is Naresh, chemistry lecturer. Today I would like to discuss one of the trick to find the bond order, and there is also a trick to find paramagnetic and diamagnetic spaces. Here the given examples, and you have to find out number of electrons, bond order, and paramagnetic and diamagnetic spaces. Again, examples, number of electrons, bond order, and paramagnetic and diamagnetic spaces. We have to find that. First, we have to find out number of electrons. First one example, S2 plus. S2 plus. Already you know that atomic number of hydrogen is 1. Already you know that atomic number of hydrogen is 1. There are 2 hydrogen atoms, 1 plus 1. And there is a positive charge. Positive charge nothing but 1 electron is less. Now 1 plus 1 minus 1 equal to 1. Now hydrogen. Hydrogen contains how many electrons? 1 plus 1, 2 electrons. S2 negative charge. That means 2 hydrogen atoms, 1 plus 1, and 1 negative charge nothing but, so 1 negative charge nothing but 1 electron is excess. We have to add 1 electron, 3 electrons. He2, helium atomic number 2, and there are 2 helium atoms, 2 plus 2 equal to 4. Now Li2 plus, lithium atomic number 3, and there are 2 lithium atoms, 3 plus 3, and there is a positive charge. We have to subtract 1 electron, 5 electrons. Li2, 3 plus 3, lithium atomic number 3, 3 plus 3 equal to 6. Li2 negative charge, 3 plus 3 plus 1, 7 electrons. Beryllium atomic number 4, 4 plus 4, 8 electrons. B2 positive charge. Boron atomic number 5, 5 plus 5, and positive charge nothing but 1 electron is less, 9 electrons. Boron atomic number 5, 5 plus 5, 10 electrons. Now C2 positive charge. Carbon atomic number 6, 6 plus 6, and 1 electron is less. Positive charge nothing but 1 electron is less, 11 electrons. Now carbon C2, 6 plus 6, 12 electrons. N2 positive charge. Nitrogen atomic number 7, 2 nitrogen atoms, 7 plus 7, and 1 positive charge nothing but 1 electron is less, 13 electrons. Nitrogen molecule, 7 plus 7, 14 electrons. O2 positive charge. Oxygen atomic number 8, there are 2 oxygen atoms, 8 plus 8, 1 positive charge nothing but 1 electron is less, 15 electrons. Next O2, 8 plus 8, 16 electrons. O2 negative charge, 8 plus 8 plus 1, 17 electrons. F2, fluorine atomic number 9, 9 plus 9, 18 electrons. F2 negative charge, 9 plus 9 plus 1, 19 electrons. Ne2, neon atomic number 10, 10 plus 10, 20 electrons. Now we have written that number of electrons present in this species. now we have to find out bond order. In the bond order, there is a trick to find the bond order. Now take nitrogen molecule. Already you know that how many electrons present in nitrogen molecule? There are 14 electrons. So nitrogen molecule always has bond order 3. Nitrogen molecule has always bond order 3. Now when we are moving forward, that means above nitrogen molecule, when we are moving forward, for every 1 electron increases, there will be 0.5 bond order decreases. 2.5, 2, 1.5, 1, 0.5, 0. When we are moving forward, there will be 0.5 bond order decreases for every 1 electron increases. Next, below nitrogen molecule. Now below nitrogen molecule, when we are moving backward, for every 1 electron decreases, there will be 0.5 bond order decreases. Now 2.5, 2, 1.5, 1, 0.5, 0. For 8 electrons, the bond order will be 0. Now we have to find out 1 to 7 electrons. 1 to 7 electrons bond orders. You have to remember one sequence is there. You have to remember that sequence. So if 1 electron is there, the bond order should be 0.5, 1, 0.5, 0, 0.5, 1, 0.5. So this is the sequence: 0.5, 1, 0.5, 0, 0.5, 1, 0.5, 0. This is a sequence. Okay, in this way we can find out the bond order. First you should remember the bond order of nitrogen molecule. So the nitrogen molecule bond order is 3. When we are moving above nitrogen molecule, there will be decrease 0.5 bond order for every 1 electron increases. Below nitrogen molecules, when we are moving backward, for every 1 electron decreases, there will be decrease 0.5 bond order decreases. Now we have to find out para and diamagnetic species. Para and diamagnetic species. You have to remember one thing, that even number of electrons always diamagnetic, except 10 and 16 electron species. Except 10 and 16 electron species. Odd number of electrons always paramagnetic. Even number of electrons always contains diamagnetic, except 10 and 16 electrons. Even though these are even numbers, these does not show diamagnetic. These only show paramagnetic. 10 and 16 electrons can show only paramagnetic. Now S2 plus, it contains 1 electron, that is hard, paramagnetic. S2 hydrogen molecule contains 2 electrons, that is even diamagnetic. S2 minus, S2 negative charge contains 3 electrons, that is odd, paramagnetic. He2 contains 4 electrons, that is even diamagnetic. Li2 positive charge 5 electrons, that is paramagnetic. Li2 molecule contains 6 electrons, that is even number, diamagnetic. Li2 negative charge, it contains 7 electrons, odd number of electrons, paramagnetic. Be2 contains 8 electrons, that is even number, diamagnetic. B2 positive charge contains 9 electrons, odd number of electrons, that is paramagnetic. B2 contains 10 electrons, that is even number. Even though boron B2 contains 10 electrons, it does not show diamagnetic. It shows only paramagnetic because it contains unpaired electrons. So odd number of electrons paramagnetic due to presence of unpaired electrons. Even number of electrons always show diamagnetic because no unpaired electrons. But the species which contains 10 electrons and 16 electrons show paramagnetic due to presence of unpaired electrons. So boron contains unpaired electrons due to presence of unpaired electrons. it will show paramagnetic. C2, next C2 positive, it contains 11 electrons, odd number of electrons, it shows paramagnetic. C2 molecule contains 12 electrons, it is even number of electrons, diamagnetic. N2 positive contains 13 electrons, it is odd number of electrons, it shows paramagnetic. N2 molecule contains 14 electrons, it is even number of electrons, it shows diamagnetic. O2 positive contains 15 electrons, it is the odd number of electrons, it shows paramagnetic. O2 contains 16 electrons, it is even number. Even though it is even number, it does not show diamagnetic, it only shows paramagnetic. It shows paramagnetic. So due to presence of unpaired electrons, it shows paramagnetic. Next, O2 negative charge. So number of electrons 17. Odd number of electrons, it shows paramagnetic. F2 molecule, it contains 18 electrons and it is even number of electrons, it can show diamagnetic character. F2 negative charge, it contains 19 electrons, odd number of electrons, it shows paramagnetic. Ne2 molecule contains 20 electrons, it is even number of electrons, so diamagnetic character. In this way we can find out bond order and paramagnetic and diamagnetic character. Now the small thing is that in this species which molecule does not exist. Which molecule does not exist? Already you know that the molecules which shows bond order 0. The molecules which have bond order 0, the molecules does not exist. He2 does not exist because He2 bond order is 0. That's it, does not exist. Next, Be2 molecule also does not exist because the bond order is 0. That's why the Be2 molecules also does not exist. And next, Ne2 molecule also does not exist because it has a bond order 0. So in this way we can find out bond order and paramagnetic and diamagnetic species. I hope that you understood this concept. Thanks to all for watching my video.